recording, and let's pick up where we left off before with a little bit of review. So we've been talking about factoring, and the three levels you always look to is you always start out with, is there a greatest common factor? Okay? This is a problem where there is a greatest common factor. What is it?
60.
What is it?
60?
Remember, the greatest common factor, it's not the multiple. It is the largest number that divides evenly into both of these terms.
2.
2 what?
2x.
Yeah. In other words, I can divide 2x into both 10x squared and 6x. What am I left with after I do that?
5x plus 3x.
3x, remember, always multiply the terms back together again to see if you get what you started with. Is 2x times 3x 6x?
Yeah.
No, it's 6x squared.
Oh.
So we don't need the x. Remember, what we're doing is we are dividing 6x by 2x. Well, the x's cancel, and you just get 3. Okay? That is what you always want to look for as a starting spot. When they give you a quadratic or even a cubic or quartic or any large polynomial, and they say factor it, the very first thing you look for is greatest common factor. Okay?
Yeah.
The second thing you look for is dopes. What does dopes stand for? I can't believe I've never used this before. Difference of what?
Well, difference of operations.
Difference of perfect squares. Okay, in other words, why is this the difference of perfect squares? Well, because that's a perfect square, that's a perfect square, and we're subtracting them. So that's why it's the difference of perfect squares. How does this factor? This is very easy to factor. It's 2 parentheses, but they're very similar to one another. What's this first one? To get this first letter, take the square root of this. What's the square root of x squared?
X.
Okay. To get the second number, always a negative as the very first thing, take the square root of the second number.
5.
And then what's the other half of it?
Same thing, x is 5.
X plus 5. In other words, it's always the opposite signs. Now, I could write this x plus 5 times x minus 5. That's the same thing. Doesn't matter, the order. But there's a reason I always put the negative first. And it has to do with the fact that at the next level of algebra, you're going to be dealing with difference of perfect cubes and sum of perfect cubes. And the way you memorize it is very important. So I almost insist that everybody memorize it with the x minus. In other words, what we're looking at here is a squared minus b squared always factors into a minus b times a plus b. And notice what a is. A is the square root of a squared. And b is the square root of b squared. So to get a and b, that's all you have to do. Okay, let me give you a harder one, just to make sure we reinforce this. What is a and what is b?
A is 2x
What is b?
minus
Go ahead.
3y
Times.
times 2x plus 3y.
Yeah, you don't have to do any effort in the second part. Just put the same thing with different sign. Okay? So that's difference of perfect squares. And that's pretty easy when you think about it. I mean, it's easy to do greatest common factor. It's easy to do perfect squares. All right. Where it gets different is when you get into the factoring where it's a quadratic with three terms. It has an x squared term, it has an x term, and it has a constant. Can I take a greatest common factor out of that?
No.
How about if I change that to x? Can I take a greatest, or 8, excuse me. Can I take a greatest common factor out of it?
Yeah.
Trick question, no.
Okay, I was confused.
What would the greatest common factor be, do you think? Well, if it read like this, x squared minus 8x plus 20, what would you think the greatest common factor would be? Remember, it has to divide into that term, and that term evenly.
I have no idea.
Well, you were probably thinking 2. Because 2 divides into that term, 2 divides into that term evenly, but 2 does not divide into that term evenly. In other words, I end up with 1/2 x squared. So a greatest common factor has to divide into all 3 terms. And whenever you have a quadratic like this, where the third term does not have an x with it, then there is no greatest common factor, ever. Because this doesn't have an x, and this has a coefficient of 1. Now, if I stuck a 2 there, is there a greatest common factor now?
Well, can 2 divide into that 2 that has the...
Yes, it can. In other words, yeah. In other words, this does have a greatest common factor, and it's 2. And what am I left with? Well, I'm left with 2 times. Remember what factoring is. It's unmultiplication. It's undoing multiplication. So what I'm left with is x squared minus 4x plus 10. So if that was the problem, the very first step would have been to try to find a greatest common factor. Remember, our goal is to factor this completely. Well, this is the first step. The next step would be to factor this part. Okay, so I get the product of three things. But this is the tough part of factoring. Greatest common factor and dopes, that's pretty easy. Right? You would agree?
Yeah.
Okay. This kind of factoring is a little tougher. This one, they go out of their way to teach all kinds of complicated systems. They might call it the California method, the diamond method. Well, I've got my own method. Now, my method works really, really good if the coefficient of the x squared term is 1. Okay, the moment you make it 2 or 3 or some other number, then we have to go to a more complicated system. But as long as it's 1, and that's certainly where you're going to start out with when you do your algebra class, is with quadratics that have a coefficient of 1 on the x squared term. There are 3 steps to factoring this. Tell me the first. In fact, verbalize it. You want to split apart the x squared term.
Yeah.
How do I split that up?
How do you divide it by...
Well, now hold on. Remember, the only requirement is that, remember what I'm doing here. I'm unmultiplying these. Well, if I had this x minus some number times x plus some number, the first stage in multiplying it together would be to multiply the x times the x. In other words, this term has to equal whatever this is multiplied by that. So the first step in factoring these is to split apart the x squared. Now, it's easy when it's just x squared. It always splits apart into x and x. It gets tougher as there's a coefficient here, because if I put a 4 in front of there, now it might split apart into 2x times 2x, but it could split apart into 4x times 1x. So whenever you get numbers other than 1, these problems become more difficult. So let's master the easy ones. Trust me, you can master that, and these first level ones, you're going to do fine. Okay?
Yeah.
I mean, and I'm serious, you got to master them. You got to master them to the point that no matter what I give you, you can do. Well, you're going to do great in algebra if you can do this. And it's not that hard. Okay? That's first step. What's the second step?
After that, do we have to distribute the entire problem into each parenthesis? Is that what we're doing?
No, here's what we're doing. That's step 1. Step 2, determine both sides. Okay, remember, what we're doing is unmultiplying this thing. This x squared minus 9x plus 20 is going to result when you multiply some x minus or plus some number times some x minus or plus another number. So we have to figure out, the second step is to determine both sides. Always. Just stick to these 3 steps and this will become easy as pie. But you have to memorize them. You have to memorize what the steps are. If you forget the steps, these become very tough. And a lot of people really get trapped up with factoring. They just can't get past it. And you have to be able to. You have to be able to master factoring. Otherwise, you got no hope in algebra. Okay?
Yeah.
So, step 2, determine both signs, not just one, but both. Now, these signs, I can figure out what they are by looking at that sign. Why? Because whatever these signs are end up in your last step of FOIL multiplying together. So the fact that this is a plus sign tells me what about these both signs?
They're both going to be plus signs?
They're both going to be the same. You produce a plus sign when you multiply either plus times plus or minus times minus. So it could be minus and minus. When I multiply that minus times that minus, I'm getting a plus. So it tells me that it's either minus minus or plus plus. To figure out which, go to the middle term. Look at that sign. That tells you it's minus minus. All right? Third step, probably the most important step, most complicated one. Verbalize it. I'll start. Factors of 20 that do what to do what? So factors of the constants that do what? They're either going to add or subtract what? Based on this. They have to add.
Yeah.
Because that's a plus sign. So factors of the constant that add to what?
Add to 9.
To the coefficient of the middle term. Without sign. I'm not looking for them to add to minus 9. I've already incorporated this minus sign in the fact that I made both signs minus. So I'm looking for factors of 20 that add to the number 9. What are those? Well, let's figure out factors of 20. What's my next step?
Oh, it would be
Let's figure out all the factors of 20. I want you to go through this process because this is a very useful process. How do I figure out the next factor? Set.
I'm so sorry.
If I can cut this in half and double that.
Oh, it would be 10 and 2.
There you go. Can I do it again?
Yeah, it'd be 5 and 3.
5 and 4. Remember, I'm doubling 2.
Double.
You always have to do the opposite of what you're doing to the first number. If I'm cutting the first number in thirds, then I've got to triple the other side. If I'm cutting it in fifths, I got to multiply the other side by 5. Okay? So, which of those factors add to the coefficient of the middle term?
5 and 4.
There's your answer. Now, let's talk about checking. Last time I was reviewing our session, and I saw that the very last thing we did was foiled these things back together again. Okay? And I do want you to learn the term foil. Whether they use it or not, or whether it's the best term or not, doesn't matter, but it actually is helpful in learning how to foil. What's the F stand for?
F stands for factoring?
First.
Or first?
What's that means is I'm going to multiply the two first terms together. That's going to give me x squared, okay? What's the O stand for?
Outside.
Yeah. That means next I'm going to multiply the two outside terms together. So I'm going to have x squared was the first. The two outside terms are minus 4x. What's the I stand for? Inside terms. That's these two terms. What's that? No, but what is that?
Sorry, I was like...
What is the inside terms multiplied together?
Is that 5x?
Is it minus or plus?
That's going to be plus.
Well, what I'm doing is I'm multiplying that term times that term.
Yeah, I thought there was another minus. Sorry.
No.
Yeah,
so it's just going to be minus 5x. And then finally, the L stands for what?
The L stands for
last. Remember, it kind of goes with the first. In fact, these four kind of go together. If you can remember the first two, the last two kind of come naturally. The first is the opposite of the last, and the outside is the opposite of the inside. What's the last term going to be?
The last term is going to be x.
What's this? Remember, I'm multiplying the two last terms together.
Oh, so it's going to be a positive 20?
Now, notice that in my answer, I've only got one of those, one x squared term. And I've only got one constant. But what I have two of are x's. And that's always the case. The only terms that are ever going to combine are those two. Now, minus 4x times minus 5x is what? Excuse me, we're subtracting. Minus 4x minus 5x is what?
It's going to be minus 9x.
Yeah. So these two middle terms always get combined to produce this minus 9x. Okay, that's significant because once you factored, you need to check your answer. But why go through all four terms of FOIL? I don't really need to check the first term. I know how to separate x squared. It's x times x every time. Okay? I also don't need to check the last term, the plus 20. I mean, remember what my step 3 is. Factors of the constant. So I know that that times that is going to multiply to 20. I don't have to check that answer. I should have checked it internally as I was doing it. The one term that is not clear is the middle term. So when you're checking your answer, after you've factored it together, you don't have to multiply it all FOIL it back together again. That's a lot of wasted effort. But what you do want to do is check the outside and the inside, because that's what makes up this middle term. Well, I use what I call my double smiley face method. When I multiply minus 5 times x, I'm multiplying the insides together. When I multiply the outsides together, I'm getting that. Add those two things together, and indeed you get minus 9x. That means I've done it right. So my checking process is only a 2-step process, not a 4-step process. You understand?
Yeah.
So let me erase some of this stuff and let's do some more. First step.
Okay. Split apart the x squared to
Excuse me.
3x.
One moment. One moment. Made a mistake. Okay. Sorry. Okay, so the first step is x and x. Second step.
And then second step is determine both signs. They're both going to be positive.
You got it. Third step, verbalize for me.
Alright, so
And fill in these numbers. In other words, don't just read what I've got down here. Tell me factors of 20 that do what?
factors of 20 that add to 12.
Good. Give me factors of 20.
21, 10, 2, and 5, 4.
Which factors add to 12?
10 and 2.
There's your answer. Check it for me. Make sure we have the middle term correct. What does the inside multiply to?
10x.
What's the outside multiply to?
x2, or 2x.
What do they add to?
12x.
That's what we're looking at. We've done it correctly. Cool. Good place to stop. I think you got it. We're going to keep practicing this because it's so important that you remember how to do this. This is not something I want to teach you and have you forget a month from now. Okay?
Yeah, no, I'm going to think.
Well, you know that I record each of these.
Oh, yeah.
And you can always review them. In other words, well, I can't show it to you now, but I could go to a previous one. Let me just show you what this looks like, as long as we've got a minute or two here. If you go to that Digital Math Tutor YouTube site, this is my website where I put everybody's recordings on here. Okay, yours is CM. So if I go and look at this one right here, this says CM072115. That was last Friday's session. Last Friday's date was July 17th, 2015.
Yeah.
You're the CM. So if you wanted to watch this again, just click on it and it'll start playing. You can see it's 29 minutes long, and it just shows you what you're hearing now is my voice from this session. If I want to fast forward it, I can do that. And it goes to other stuff that we were working on that day. Okay, so you don't have to watch these at slow speed. You know, if there was just something you weren't sure about, you could fast forward it directly to it. So these can be pretty helpful. So in terms of taking pictures and stuff, you don't really need to do that. Just refer back to these recordings.
Yeah.
All right, Chris, I will talk to you Friday again.
All right.
Have a good one.